Hello, it's Mr. Luneski. Today we are looking at Unit 4, Section 2. We're going to be doing a little intro to geometry proofs. My big warning at the beginning of this video is to please make sure that this is a video that you listen to, not just copy down what I write down like I know some of you are doing out there. So make sure you're listening because I talk more than what I actually write about today. Geometry proofs are a little bit different than algebra proofs. When we're looking at geometry proofs, if you recall, we start off with a given statement. And the idea in a geometry proof is that we want to squeeze out as much information as possible from that given statement. And with that given statement, we want to try to prove something new. So what we're going to be looking at in these examples here today are these things pop up a lot in geometry proofs, so I want you to know how to handle these situations when they come up in geometry proofs. So some of it's going to seem new to you, some of it's going to be a refresher from earlier chapters. So the first thing that we're looking at is the measure of angle 1 is equal to the measure of angle 2. So what I want to remind you of is that the m in front of that is referring to a numerical value. 30 degrees, let's say. So if I say that two angles are equal to each other, what I'm allowed to also say, what I can pull from that information, is that those two angles are congruent. So what I usually do is when you see that equal sign and I kind of make a figure 8 around it, I can kind of loop those things together, that congruency and equals. So that is called the definition of congruent angles. When I say two angles are congruent, I'm just saying that they have the same measure. I'm not necessarily talking about their measurements. And when I put the little m in front of that, that needs the equal sign. So for the next one, the measure of angle 1 plus the measure of angle 5 is equal to 90 degrees. So hopefully maybe that rings a bell from back in Unit 1. We could say something like angle 1 and angle 5 are complementary. We're allowed to abbreviate here. They're complementary. So anytime in a geometry proof you find yourself using a vocabulary word, there's a really, really good chance that your explanation or your reason as to why we can say this, because keep in mind all of these are whys. Why can I say that 1 and 5 are complementary? Because that's the definition of complementary, that the two angles add up to 90. So number 3, if I tell you that angle 1 and angle 7 form a linear pair, so like I just said, I like to put a box around the vocabulary word. So if I know two things are a linear pair, what can I say about them? I can say that angle 1 and angle 7 are supplementary. How do I know that those things are supplementary? That's the definition of a linear pair. Definition of a linear pair tells me that they're supplementary and adjacent. Now if you notice, we also used another vocabulary word, supplementary. So now if I know two angles are supplementary, what can I say about those two angles? I can say that those two angles add up to equal 180 degrees. Why? Because that's the definition of supplementary. So anytime you see a vocab word, there's a really good chance you're going to see definition of whatever that vocab word is to help you with your reason. Moving on, if I tell you that angle 8 is a right angle and angle 9 is a right angle, what can we pull from that? What information can we squeeze out of that? Well, we can say that the measure of angle 8 is equal to 90, and we can say that the measure of angle 9 is equal to 90. Notice we're using a vocab word, right angle. So why can I say those two things are equal to 90? That's the definition of a right angle. And now if you notice, both of these things are equal to 90. So now I could also say that the measure of angle 8 is equal to the measure of angle 9, since they're both the same thing. That is called a substitution. I'm technically substituting angle 9 into this 90, or you could refer to that as a transitive property. Next one, if I tell you that angle 4 and angle 7 are complementary, I'm using a vocab word. So complementary means that the measure of angle 4 plus the measure of angle 7 is equal to 90 degrees. Why? That's the definition of complementary. Here's my vocab word, here's my reason why. Number 6, if I tell you that angle 1 is congruent to angle 7, just like we did at the beginning, I can figure 8 that and say that the measure of angle 1 is equal to the measure of angle 7. And that is also the definition of congruent angles. So you're allowed to abbreviate these things too in the notes. You don't have to write the word congruent. You don't have to write the word angle. You can abbreviate wherever you need to. So that works both ways. I can go from congruent to equal or equal to congruent. The next one, if I tell you that the measure of angle 1 plus the measure of angle 4 equals 180 degrees, that tells me that angle 1 and angle 4 are supplementary. I'm using a vocab word, supplementary, so my reason is the definition of supplementary angles. Next one, angle ABC is a right angle. Vocab word, what do right angles tell me? It tells me that the measure of angle ABC equals 90. Notice because I'm talking about the number, I need to include that little m now. That's the definition of a right angle. Next one, angle 8 and angle 9 are vertical angles. Vocab word. So anytime you have a vocab word, put a little box around it. So when I know that those are vertical angles, what can I say? I can say that angle 8 is congruent to angle 9. That's the definition of vertical angles. Vertical angles are congruent to each other. And now because I know that they're congruent, what else can I do with that? Configure 8 it. I can say that the measure of angle 8 is equal to the measure of angle 9. That's the definition of congruent angles. Switched from congruent to equals. The next one, DB is equal to SG. That's referring to segments, the lengths of segments. So just like we were doing with angles, if I have equals with segments, I can turn equals into congruents. And I can say that DB, segment DB is equal to segment SG. That's the definition of congruent segments. If I tell you that AB, ray AB bisects angle CAD, so my vocab word here is bisect. If it helps to draw a little example here, CAD, here's B. So what can I say about that? Well, if AB is bisecting CAD, what does a bisector do? It cuts the angle in half. So I can say, for that one, that the measure of angle CAB is equal to the measure of angle BAD. Why? That's the definition of an angle bisector, saying that those two angles are equal to each other. Just like we did earlier, when I have equals, I can loop that around and make that a congruency statement and say that angle CAB is congruent to angle BAD. That's the definition of congruent angles. Next one, I'm saying that the segments, whoops, this should be congruent, saying that the two segments are congruent to each other. So now, just like before, I can switch that over to equals and say that MA is equal to TH. And that's the definition of congruent segments. Couple more. TI is equal to FG and FG is equal to SD. If we notice here, we are repeating FG. That's our middleman. So what can we say? We can say that TI is equal to SD, and that's our transitive property or substitution. If I tell you that DMB is a right angle, vocab word, what can I say? I can say that the measure of DMB is equal to 90 degrees, and that's the definition of a right angle. Midpoint, M is the midpoint of AB, if it helps you to draw that out. Here's A, here's the midpoint, here's B. Midpoint is a vocab word, so we're probably going to use that somewhere. So what can I say with definition of midpoint? I can say that AM is congruent to MB, and then I can loop that around. So why can I say that? That's the definition of a midpoint, that these two pieces are congruent to each other. And then I can switch that over to being that AM is equal to MB, definition of congruent segments. And then our final little property here is that if B is between A and C. So notice it doesn't say it's the midpoint, it just says it's between it. So I'm just going to draw it like this. So what can I write? And this goes back to Unit 1. I can say something along the lines of AB plus BC is equal to AC. And we refer to that as segment addition. Part plus part equals whole. So let's take a look at a couple quick little properties, some things you may remember from before. Remember, symmetric property is just when the two sides are switching. Reflexive property is anytime you state that something is equal or congruent to itself. So AB is congruent to AB. And then transitive property, we talked about that. That's when you just sort of cut out the middleman and smush the other ends together. So we're going to take a look at two proofs here, and then that'll be it for the video. So in our proof, we are given that AB is congruent to CD, and we're trying to prove that AC is congruent to BD. So we're trying to prove that this piece is equal to that piece, essentially. So one thing that I recommend is, and I'm going to give my students highlighters, is always highlight your given statement, because sometimes it's very easy to forget given, and that should always be an easy step. So step 1 is my given. And now if you notice what happens in the next step, we're switching from congruent to equals. So what do we call that? We call that definition of congruent, and we're working with segments, so congruent segments. So now for this one, we're saying BC is equal to BC. So BC equals BC. If I say something is equal to itself, that's reflexive property. And now if you look here, anytime there's an addition that all of a sudden comes into play, something's kind of going on with the figure. So you may want to reference the figure. So check out the figure. And if we look, AB plus BC, AB plus BC equals AC. So what did I just do? I just did part plus part equals whole. What do we call that when we do part plus part equals whole? That's segment addition. If we look down at the next part, we have CD plus BC. CD plus BC equals AC. So that doesn't fit our mold of part plus part equals whole. So what happened? Well, we had this, and now all of a sudden it's becoming CD. And if you take a look, AB got replaced with CD. Why did I do that? Well, because they're equal up here, which means I can substitute them out. So this step here is substitution. If we look at the next step, CD plus BC is equal to BD. That again is just part plus part equals whole. So that's segment addition. And now the next step just says AC equals BD. Once again, if you notice here, CD plus BC and CD plus BC is occurring twice. And each time we say that, we're saying that it's AC and BD. So if both of those things are equal to CD plus BC, that means I can set them equal to each other. So this is another substitution. Say substitute. And then finally, what happens? I go from equals back to congruent. So that's our definition of congruent segments. So you may be wondering, why did I switch from congruent to equals? Can't I just do all these operations? Unfortunately, you can't. You can't add and subtract stuff when you're dealing with congruency. You can only do that when it's the equal sign. So you always have to switch. Okay, that's one proof. And we'll take a look at one dealing with an angle. So if I tell you that ray AB is bisecting angle CAR. So once again, I recommend with a highlighter, highlight our given. There it is. I know my first step is given. So what can we pull from knowing that something is a bisector? We can say that CAB is congruent to BAR. Now remember, we used a vocab word. We used bisect. So that means this is going to be definition of angle bisector. If you notice here, what happens? I switched from congruent to equal. So that's definition of congruent angles, because now we're talking about angles. So now if I say that CAB, this angle here, is equal to BAR. So now the next step says that CAR, angle CAR is the whole angle, is equal to CAB plus BAR. So what did I do? I did part plus part equals whole. So earlier we were calling that segment addition. Well, now I'm not adding segments, I'm adding angles. So this is angle addition. Now if you look at the next part, CAR equals CAB plus CAB. So what happened was BAR got replaced with CAB. How am I able to replace it? Because of this step right here. CAB is equal to BAR. So this is a substitution. And now the rest of this almost looks like an algebra proof. CAB plus CAB adds together to become 2 CAB. So I just combined like terms here. CLT, combine like terms. And remember what we're trying to prove. We're trying to prove that angle CAB is equal to 1/2 the measure of angle CAR. So now I need to get this to become 1/2. So now to get rid of this 2, divide both sides by 2. So that's my division property of equality, or my division PO. You can write it that way to abbreviate. And finally what happens is these two things here are just switching places. That is our symmetric property. Alright, we are going to practice these proofs some more in class. Keep this note handy. This will probably be one of the most important notes that you have for the unit. Thank you for watching.